Hey guys, this is some test prep for your test on Thursday. We'll do part of it today, Wednesday, and then we'll do the other part on Thursday morning. So you'll have two videos you need to watch to get your participation points, and you can just leave this in my room after each hour so I can just check off that you did it. So, the first question on your test, by the way, make sure your note card's ready to roll too. We talked about that a little bit. Any day you're absent, make sure you add stuff from your notes to your note card. The first question that you're going to get on your test is, are the triangles congruent? So it'll be a yes or no question. If your answer is yes, you need to tell which postulate or theorem you're using. Here's your options. Side, side, side. Side, the angle smash between them, side. Angle, the side smash between them, angle. Angle, angle, side, or the most recent one for right triangles only. Only if you have right triangles would you even try this one, hypotenuse leg. So let's start. First of all, you take into account what they've given you. I like to write it down. I say, well, they gave me a pair of sides right here. They gave me another pair of sides right here. I immediately know that my winning pair is most likely, not for sure, but most likely going to be either side, 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 or side, angle, side. Otherwise, why would I have two pairs of sides? So what I need to do is do what I call adding my brain to the picture. I see this scooted over a little bit. So I can see these are butting up against each other, and they have to share this third side. It's on both of them. What that now gives me is side, side, side. So I'd say yes, they are by side, side, side. So your answer is either a yes or a no. If you write no, you write not enough info. If you write yes, you write one of those 5 reasons. This one won't happen more than once. So if you're writing hypotenuse leg on all of them, you're not going to do very well. All right, so the next one up, let's go see what I've got as I go around here. I've got a pair of angles. I always like to go from left to right. I've got another pair of sides. And then I've got another pair of sides, and it's not the angle smash between the two, it's the angle on the outskirts of the two. This is not enough. This combination is not enough for you to say the triangles are congruent. So you'd write not enough information, not enough info. Now, let me talk about how you could have it marked differently and it changed the answer. If instead of that fella, it was this one, then as I travel around, I'd have side, right here. I'd have angle right here. And side right here. Notice it's the angle smashed between the two sides that I have. So that would be a yes by SAS if it had been marked that way. But the way it was marked, it was ASS, and that's not enough information. So let's go to the next one. We'll take what they gave me. Nice pair of sides, thank you very much. Another pair of sides, thank you very much. And nothing else. Remember for the bow tie picture, you can always add the vertical angles. And it's the angle smash. Look when I read it from left to right, it goes side, angle, side. So this would be a yes by side, angle, side. So the question is yes or no, if so, by who? This might be a candidate for hypotenuse leg, but there's no way for me to get the hypotenuses the same, so that's out. But these are butting up against each other, so they share a side right here. And now I've got a side right here and right here. The angle smashed between them is marked as a right angle. And then I add, with my reflexive property, another pair of sides. So this would be a yes by SAS. The next one you might go, well, this is angle side side. She said there's no AS proof, so not enough information. And if this had been any other angle measure here except the right angle, you'd be correct. But this is actually hypotenuse, the longest side, or the side across from the right angle, and leg that they've marked. So this is that special case of a right triangle. When they mark the hypotenuse and the leg, you can say yes by hypotenuse leg. Remember, the hypotenuse is that longest side. On this one, that was not marked for me. So what do I have going on this one? Looks like I've got some parallel runners. That allows me to steal alternate interior. I also have a bow tie, which allows me to steal in here at the center. So when I add my brain to the picture, I just added 2 more pairs of angles with alternate interior and that, and they gave me the side smash between them. So this would be a yes-siree by ASA. And again, I'm going to take my markings off and show you what I did. I said because they're parallel, alternate interior are the same. Because it's a bow tie, vertical angles gives me these the same. I'm now sitting there with angle, side, angle when I go left to right. Lovely, lovely. All right, next up, what are they giving me? They are giving me some angles right here and right here. Thank you. Some more angles right here and right here. I now know that these two are probably not my winner. Why would they give me 2 pairs of angles if they're trying to get me to do a sassy proof, right? So my brain adds to it. Anytime I see them butting up against each other, my brain hops on and adds the shared side right here. So now you'll notice I've added the side on the outsides of the angle. It goes angle, angle, and then side when I go left to right. So this would be a yes by angle, angle, side. Number 8, go mark what your brain can add to the picture first, and then you answer that one. I'll give you a minute, not even a minute. There's definitely a for sure your brain should add it, and then we'll see what we have. My brain adds this. I'd be careful before I write sass because remember, I read it from left to right. This goes angle, side, side. There is no ass theorem, so this is a no, not enough information, not enough information. And lastly, number 9. We've had this one a lot when they butt up against each other, which they do a lot. They did on about 3 or 4 of these. The bow tie and the butter upper are pretty common. I get to steal this 3rd pair of sides. So this is a yes by SSS. So that's the first part of your test. It's basically just a bunch of those. I don't know how many, 6 to 9, I think. It's either 2 rows of 3 or 3 rows of 3. Then we're going to use our knowledge about isosceles and equiangular equilateral triangles to find indicated variables. So this first one over here, number 10, by marking these this way, I'm telling you that it's isosceles, which means not only are 2 sides the same, but the angles across from each other, called the base angles, are the same. So I'll start this one by saying base angles, you guys are equal. I can get x pretty handily, pretty easy, right? X is 21. How do I get y? Well, I've got 2 angles down at the bottom that are the same. They're 63 on the right, and the other one's 63, which means I have 126 degrees taken up inside that triangle, and we know that the sum of the angles in a triangle is 180. So y would be 54. And you can always check it on your calculator by trying 54 plus 63 plus the other 63, and those 3 yellow ones should add up to 180. So really watch the markings for these, whether they're marking isosceles or equilateral. For an equilateral triangle, we know all the angles are the same. We actually know what they are. They're 60 degrees. But that doesn't help me because those values are on the outside. But if all the angles are the same, all the sides are the same too. So that makes it pretty nice. I've just got to really think about who I decide to solve for first. I could set 7x equal to 3y, but I would get stuck. So I'm going to set 7x equal to 42 first to help me get the x. All sides are the same, and all angles are the same for an equilateral. But all the angles we know are 60 degrees. Not helpful on this one because I'm working with the sides. So I'm just going to set the sides equal to each other. 7x equaling 42 means that x would be 6. And then 3y also equals 42. So grab that nice one and set the other 2 equal to it. When I divide 42 by 3, I get a 14. Now I've got an equilateral triangle with all sides being 42. When this is 6, I'll have 42, And when this is 14, I'll have 42, and this one was given as 42. On the next one, number 12, what do I have marked? I have an isosceles triangle. What do I know? The angles are the same, but the stuff isn't on the angles. It's on the sides. Well, those are marked the same as well. So I'll just set those sides equal to each other. Use a little algebra 1 to solve it. We'll need to get the variable on the same side. Get out of there, 3x, you'll into y. I'll get x minus 10. I'm going into my southern accent now, y'all. Just because I'm getting a little squirrely and a little bored here talking to myself in my room up at my smart board. Negative 2 plus 10 is 8. X is 8. Perhaps a little checking might be in order. Whoa, where are you going? I'm Stephanie in for X, man. So I get 3 times 8 is 24. Minus 2 is 22. Let's go see if it works over here. Whoa, 4 times 8 is 32. Minus 10 is 22. Notice both sides are 22. Moving right along. Congruent statement tells me who is congruent to who. All parts are matched up accordingly. So when you're asked to find who's congruent to who, you just say, well, P is the first one listed will be the same as angle T, the first one listed. Make sure you put an angle and then a T. Have proper notation. Who is QR the same as? Well, QR is the middle and the last. It'll be the same as the middle and the last. UV with a segment bar over the top of it. RP is, let me get another color. RP is last first, so I will list last first, VT. VT, baby. Angle U, right smack in the middle, goes with angle KU, right smack in the middle of an Oreo cookie. Is a delightful creamy white frosting. All right, number 14. Write a congruent statement. Now they're giving me a picture, and I have to tell you who is congruent to who. State it. Well, you get to pick these in any order that you want. I'm just going to go A, B, C because it seems the most logical. But it's a triangle, so I put the symbol in front of it. So watch your notation. Over here, who goes with who? I have to be careful now. I started with A. A has 2 arcs. So I must start with N because N has 2 arcs. Then I went to B, and B has 1 arc. So then I have to go to M because M has 1 arc. And L is out there all alone at the peak. And that one's done. I wanted this to take no more than 15 minutes, and I think I shall reach my goal. Number 15, state what additional information needs to be given. Why did she say it like that? Because it's not the stuff that your brain adds to the picture that we're looking for. We want to know what else needs to be in a given for you to say the triangles are the same. So take a look. Now it's kind of the reverse of the first page. They're saying you need to get SSS, kiddo. And we're only going to give you 1 pair of sides. And then your brain says, but these are butting up against each other. You need to add the other pair that would need to be given. So I would have this marked, this from my brain, and this is the piece that I have to, the unhighlighted part is what you need to add. You would say AB would have to be exactly the same as CB if I'm going to say these are congruent by side, side, side. So it's the stuff that your brain does not add to the picture that you need to list. So here we have again, the bow tie. Do you think you're going to have stuff butting up against each other and sharing a side? Yes, it's happened a zillion times. Also this bow tie, you get to steal the vat, man. What do I have? I have 2 angles now. What they're asking you for is what else needs to be marked so that it goes angle, angle, side. And you can see it's these 2 sides here that I would need to have given to me for me to do it. PL the same as PR. And I did not put the theorem on here. Let's say this one says by hypotenuse leg. So let's go see. We've got the right angle, so I know it's a candidate. They gave me the legs the same. So if I wanted to prove these are the same by hypotenuse leg, I would need the hypotenuses to be the same. I like that word, hypotenuses. Almost as good as isosceles. All right, what's the hypotenuse on the left one? FG, y'all. What's the hypotenuse on the other one? MP. So again, it's not the stuff your brain adds to the picture, it's what's missing that you need to provide. And last but not least, figure out what X and Y are. Well, I know the triangles are congruent. So I know that since all the stuff is on the side lengths, corresponding sides are the same. So I know that XH is exactly the same as AB. What does that mean? 15 has to equal 3y. That's solvable. But watch if I tried to do the other one first. Suppose I decided to go try ZH and then set it equal to BC. I'd have a hard time with that because I would have two unknowns in the problem. So you have to start by finding y first. You'd say 15, you have to equal 3y. Y falls in your lap. It's got to be a 5. Once you have it, though, it can go up and get plugged in. So this is no longer 2y minus 2. It's 2 times 5 minus 2, which is 10 minus 2, which is an 8. And that helps me get x, because I say 3x minus 11, you're equal to 8. And then I say 3x, you are equal to, and it's not going to work out nice, 19. Sorry, I made one that doesn't work out nice. And then you divide by 3 and be done. Make sure your name's on the top of this. You should have all the work on there that I did, and you'll get full participation points for this. We will do the proof part tomorrow. Have a good one.